The heart of our planet isn't still. It spins, surges, slows down, and recently, something has changed. From unexplained anomalies to major surface disruptions, the signs are no longer subtle. They scream.
In a shocking revelation, researchers discovered that the Earth's solid inner core, once thought to rotate steadily, has slowed down. And worse, it may be reversing relative to the mantle. Like a heart skipping a beat, the Earth's innermost engine is stalling. This irregular motion disrupts Earth's magnetic field and could signal deeper turbulence brewing inside. Our magnetic north is no longer fixed. It's racing across the Arctic, moving from Canada towards Siberia at unnatural speeds. This shift isn't random. It's a compass needle reacting to chaos beneath our feet. The geomagnetic field, powered by the core, is behaving like it's being pulled by forces we don't fully understand. Or worse, forces no longer stable. A strange weakness in Earth's magnetic field, stretching from South America to Africa, has been growing. Satellites glitch. Cosmic rays seep closer. This region, known as the South Atlantic Anomaly, is a fingerprint of inner core instability. It's a wound, and it's getting wider. Time itself is shifting. Not metaphorically, literally. Earth's day length has fluctuated due to subtle changes in inner core rotation. Some days are a fraction of a millisecond shorter. It may sound small, but this suggests the very mechanics of our planet's spin are no longer smooth. Something is dragging time. More deep-focus earthquakes are being recorded, in places and at depths where tectonic activity shouldn't exist. These seismic pulses, hundreds of kilometers beneath the surface, are not crustal cracks. They are echoes from the core mantle boundary, like stress signals rising from Earth's tortured interior. Beneath our continents, unusual hotspots are forming where heat flow is abnormally high. These aren't regular magma chambers. They're signals from the core mantle boundary where intense thermal exchange indicates a core under strain, leaking its energy unevenly. A fever Earth can't cool. The Geodynamo, the mechanism generating Earth's magnetic field, requires a stable, swirling liquid core. But now, evidence suggests irregular flow patterns are emerging. The generator is losing rhythm, and if it stops, Earth becomes naked to the sun's deadly radiation. Strange low-frequency electromagnetic waves have been detected from deep underground, too deep for tectonic activity. These electromagnetic anomalies could originate from the changing state of the outer core, signals that something is moving, shifting, or cracking within Earth's magnetic heart. When earthquakes send seismic waves through the planet, their speed changes depending on what's inside. Recently, scientists detected uneven speeds in waves traveling through the inner core, suggesting its structure is changing. The inner core is no longer uniform. It's fractured, layered, unstable. Volcanic systems like Yellowstone and La Palma are showing unusual behavior, not just crustal shifts, but signs of being fed by plumes rising from deep within the Earth, possibly from the core mantle boundary. These aren't ordinary eruptions, they're pressure relief valves from Earth's engine room. If Earth's core continues to weaken, the signs won't stay hidden for long. We'd see a noticeable rise in seismic activity, not just more earthquakes, but more frequent and clustered quakes across fault lines once considered stable. Volcanoes would begin erupting in groups rather than in isolation, triggered by shifts in mantle pressure as deep thermal convection becomes unstable. At the same time, the crust could respond with sudden ruptures, landslides, and abnormal tectonic movements in areas far from the usual danger zones. Supervolcano systems, long dormant, might begin showing signs of awakening due to the redistribution of heat and pressure below. What once required tens of thousands of years to build up may accelerate in mere decades. Underwater volcanoes, often ignored, would become increasingly active, releasing massive amounts of heat and gases into the ocean. This could disrupt marine ecosystems, trigger methane bursts, and even cause localized sea temperature spikes. In extreme cases, submarine eruptions could set off undersea landslides, generating unexpected tsunamis in regions far from tectonic hotspots. The magnetic field would weaken further as the molten iron flow slows down, exposing us to higher radiation, distorting animal migration, and even allowing auroras to reach the equator. Electrical blackouts, satellite failures, and navigation disruptions would become common, not rare. Weather patterns would shift in unpredictable ways. Heat trapped unevenly in the atmosphere may lead to simultaneous droughts and floods, a broken balance of water, air, and temperature. Ocean currents could stall or redirect, bringing cold to warm places and heat to cold ones, destabilizing ecosystems and agriculture worldwide. Eventually, the compounding effects would begin to cripple infrastructure. Communication systems could fail without warning, transportation hubs would halt under extreme conditions, and national power grids might collapse beyond repair. Countries heavily reliant on stable energy, trade routes, and precise weather forecasting could find themselves paralyzed, not by war, but by nature's slow but unstoppable shift beneath their feet. All this would not happen in one day, but signs would stack, faster than we've seen before. And if we don't understand the warnings from deep within the planet, we might be too late to prepare for the surface consequences. So the real question is, are we paying attention to the symptoms of a planet in distress, or are we still pretending the ground beneath us is unbreakable?